Okay, fifth graders, here we go. Lesson 1, section 1. And you can see what I circled here, kind of highlighted, lesson 1-1, and it's pages 6, 7, and 8 in your math volume 1 workbook. And so this is the first video of the year that I'll be doing with you guys. And there's different formats that I use, but this is generally it. So we're looking on page 6 here, and if you guys don't have your math book, you want to open it up to page 6, and let's take a look at this here. So it says Tamara's new horse weighs about 1,000 pounds. It says, how can you show 1,000 as a power of 10 using an exponent? Okay, so I don't know how much you guys remember from 4th grade. I don't even know if they teach you guys about exponents in 4th grade. And then it says here, the exponent is the number that tells you how many times a base number is used as a factor. Well, okay, first off, what's a factor? A factor would be a number that you would multiply something by. That would be a factor. And so I'm dropping down a box here, and it shows us some factors, 10, 10, and 10. Those are factors. And then we've got exponent right here, and that little 3 is the exponent. And this 10 is the base. Now, the base really could be anything, okay? I mean, I could write a number, 46, and give it an exponent of 7, okay? That's the 46 is the base, and the 7 is the exponent. I could have 1,220 and have an exponent of 2. The 1,220 is the base, and the little 2 there is the exponent. So don't get those confused. The base is the number that the exponent is attached to, and the exponent tells you how many times that particular number would be factors. Okay? So it says the exponent 3 shows that the base number 10 is multiplied 3 times. Okay, notice that the little 3 means that the 10 is going to be multiplied 3 times by itself. So writing 1,000 is the same as 10 to the third using exponents. Okay, let's look at C here for a moment. The next box over, it says Tamara estimates that her horse will eat about 5,000 pounds of hay each year. How can you write 5,000 using exponents? So they give us some examples here. Let's look at the very first one here. So 5 times 10 to the first, or something with an exponent of 1, is really the same thing as 5 times 10, when that equals 50. Okay? So 5 times 10 squared, that's the same thing as a number with an exponent of 2, it's called squared, is equal to 5 times 10 times 10, which equals what? 500. You guys know that. All right. The third example they give here is 5 times 10 to the third. Okay. Or you might even hear cubed. I might say cubed once in a while. Squared would be 2, cubed would be 3. But anyways, 5 times 10 to the third power is 5 times 10 times 10 times 10, and that equals 5,000. So look what they're pointing out here. If the base is 10 and there's one exponent, you're just going to add 1 0 to the number. In other words, add a 0 to 5. If the exponent is 2, okay, then it's going to be 10 times 10, which is 500, 2 zeros. If the exponent is 3, it's going to be 5 times 10 times 10 times 10. And notice 3 zeros. So what if I said 5 times 10 to the fourth? What would that equal? Well, you could take it another step and do 10 times 10 times 10 times 10 4 times. Or you could just write 5, and how many zeros do you think you would add? How many zeros do you think you would add? You would add simply 4 zeros. 1, 2, 3, 4. It's going to be 50,000. 5 times 10 to the 5th, how many zeros do you think I'm going to add? 5, how many zeros? 5 zeros. 1, 2, 3, 4, 5. How do I know where to put that comma? Do you guys know that? Know the answer to that? You just start on the far right side, which is here, and then just count over by 3. I'm going to start here. I'm going to go 1, 2, 3 places, and I'll put a comma. So I'm going to start here. I'm going to go 1, 2, 3 places and put a comma. And I'll keep putting commas until I don't have any more room. We do one more here. How about 5 times 10 to the 6th? How many zeros do you think I'm going to add? Well, I'm going to put down a 5, and I'm going to add 6 zeros. 1, 2, 3, 4, 5, 6. Where do I put the commas? So I'm going to count over. 1, 2, 3, 1, 2, 3. Okay. So if the base is 10, you just add that many number of zeros. All right. So down at the bottom here, it says, look for relationships. What pattern do you notice in the number of zeros in the products in box C above? Well, just simply write in your workbook there the number of zeros match what? The exponent. All right, you guys should have noticed that. The number of zeros match the exponent. What have we got here? Exponent of 4, how many zeros do we have? 4. Exponent of 5, how many zeros do we have? 5. Exponent of 6, how many zeros do we have? 6 zeros. All right. So I was thinking about horses. I've ridden horses a couple times in my life. I generally don't like riding things that are larger than I am. But I was kind of curious about horses here. And so this top horse, I think he's called Zeus, and he's 17 hands high. And they measure horses by the number of hands, how tall they are. And I'm not sure how many inches are in a hand. Those of you that are horse people would probably know. Maybe you could ask your parents, or maybe you know, I don't know. But the largest, or actually probably the tallest horse in the world, and I think this was taken in 2018, is Big Jake, 82.75 inches tall. And the smallest horse was Thumbelina, and she's 17.5 inches tall. I thought that was kind of interesting. I was curious about the biggest and the smallest horse there. So now you know. Okay, so let's go to the next page. The guided practice. And let's do some of these. This is going to be your homework for Monday night. I'm going to assign this video for you guys to watch, and I'll do some of these problems with you guys. And then on Tuesday when we meet, I'll kind of spot check, and I'll call you out by name, and I'll say, what did you get for this number, or what did you get for that number? So number 1 here for starters, it says, why are there 3 zeros in the product of 6 times 3 to the 10th? Well, the product is basically another way of saying the answer. Well, what is 6 times 3 to the 10th? So I'm going to put down 6. How many zeros do you think I'm going to add? 1, 2, 3. So what do we have here? We have 6,000. That's the product of 6 times 10 to the 3rd power. Okay, how many zeros are there? Well, 3 zeros. All right, number 2, Susan said that 10 to the 5th is 50. What mistake did Susan make? What is the correct answer? Well, I don't know. What do you think Susan was thinking? She just multiplied, she just did this. She just did 10 times 5. That equals 50. Okay, so all you have to do is add a 0. Well, it's not 10 times 5. It's 10 to the 5th times 5. All right. How many zeros are we going to add to the 5? We're going to add 5 zeros. 1, 2, 3, 4, 5. And now I'm going to just count over 3 and put a comma there. That's 500,000. Okay. What mistake did Susan make? Well, I kind of wrote it down there. She did 10 times 5 is 50. So you guys could just write that down. And what's the correct answer? Well, I gave you that too. In 3 and 4 here, it says complete the pattern. Isn't this nice? I'm doing your work for you. Aren't you guys happy about that? Don't you have a great teacher? Yes, Mr. Glazier, I love Mr. Glazier. There we go, because I'm doing your work for you. How nice is that? All you have to do is copy it down. So complete the pattern. So 10 to the first is what? 10. 10 squared, or 10 to the second power, is what? 100. Notice the exponents are matching the number of zeros. 10 to the third is 1. How many zeros? 1, 2, 3. I'm going to let you do the last one. 4 here. What equals 7 times 10 to the first? Well, what's that? 7 times 10. That's 70. 7 times 10 squared. How many zeros am I adding? 2 zeros. Notice the zeros, the number of zeros, match the exponent. 7 times 10 to the third, 7 and 3 zeros. Put a little comma there. Notice the number of zeros, which is 3, matches the exponent. And that's true if the base is 10. And for, I think, most of what you guys are doing here, that's what we're dealing with, which is pretty much just base 10. Okay. I'll do a couple more down here. It says find the product, which is another way of saying the answer. Product is the answer to a number where there's multiplication. Use patterns to help. Well, we can see some patterns here. 2 times 10 is what? 20. 2 times 100 is 200. 2 times 1,000 is 2,000. You guys can do these. How about number 8 here? 8 times 10 to the fourth. Okay, the base is 10. The exponent is 4. So it's going to be 8. And then how many zeros am I adding? 4. Whoops, shouldn't put a comma there. 1, 2, 3, 4. So that's 80,000. How about number 10? 5 times 10 squared, or 5 times 10 to the second power. It's going to be a 5. How many zeros do I add? 2. All right. I think you guys got this. This isn't that hard. I remember I talked to a couple of you today, this afternoon, as you guys came through and said that you're worried about math. Let's look at the bottom one here. 16, it says write 10 times 10 times 10 times 10 times 10 times 10 with an exponent. Okay? So it's going to be 10 to what? To what power? What exponent are we going to use? How many 10s do we see here? 1, 2, 3, 4, 5, 6. Okay. Last page. And then you guys are done with the video. And I generally try to keep my videos 20 minutes or less. Sometimes they're a little bit longer. Sometimes they're a lot shorter. One box of printer paper has 3 times 10 squared sheets of paper. Another box has 3 times, well, actually they don't write it, but it'd be 3 times 10 to the third sheets of paper. What is the total number of sheets in both boxes? Well, first off, what's 3 times 10 squared? What's that equal? 3 times 10, that's going to be 3, and add how many zeros? All right. What's going to be 3 times 10 to the third? What's that going to equal? 3,000. What's 3,000 plus 300? What's the total number of sheets in both boxes? What is it? It's going to be 3,300. Okay. 17's done for you. 18. A post is put every 6 feet along a fence around a rectangular field that's 42 feet, okay, and 36 feet wide. So it might look something like this, we'll say. Every 6 feet. So they're going to put a post every 6 feet, okay? So it's 42 feet long. So it's 42 feet here. That means it's going to be 42 feet here. And what are the sides? 36. 36. How many posts are needed? Well, first thing you need to do is figure out what the perimeter is. In other words, how far around it is. How would you do that? Well, add them up. 42 plus 42, 36 plus 36. Add those up. You're going to get a number, and then whatever that number is, you're going to divide it by something. And you're going to divide that number by 6, and that will tell you how many posts you need. Number 18, I will be asking somebody about that, so make sure you do it. Actually, make sure you do all these, okay? Let's do a couple more. One more, we'll do one more. Okay, maybe we'll do 2 more, I lied. Number 20, an aquarium has the same shape as the solid figure below. What's the name of that solid figure? That's called a rectangular I'm going to say it starts with a P. Do you guys know what it is? Prism. It's called a rectangular prism. I'm going to help you with 20. Let's see. How about 21? So Isaac takes 5 minutes to ride his bike downhill to school and 10 minutes to ride his bike back up from school. He attends the school Monday through Friday, so that's 5 days. How many minutes does he spend riding his bike to and from school in, 2 weeks? That's important. In 2 weeks, not 1 week, 2 weeks. It says, write an equation to model your work. Well, okay. So what's 5? Gosh, there's all kinds of different equations we could write. How about 5 plus 10? That's going to be 1 day. Okay. And then we could multiply that by 5. Okay. And then we could do it again, because it's 2 weeks. 5 plus 10 times 5 equals. All right? Kind of bled over into number 22 there, but there you go. So solve that one. Figure that one out. And 22. Oh, 22 is can be kind of a hard one if you're not good with rounding. And I don't know if I like the way they phrase it. It says Santiago, if I said that right, hopes to buy a 4-horse trailer for about $12,000. Describe all the numbers that, when rounded to the nearest hundredth, are 12,000. Okay, I'm going to just give you the answer here because I'm not sure you guys remember or how much rounding you did. So it would be, I'm going to write down, you guys copy this down here, numbers greater than or equal to 11,950 and less than 12,050. I'm going to write a number here, just a really quick review, but we'll touch more on this later here. If I wrote 12,752, okay, where's the hundredths place? The 7 is the hundredths place. Where's the tens place? I'm going to put little 100 there. Where's the tens place? This is the tens. Where's the ones place? This is the ones. Where's the thousands place? Here's the thousands. And the final, the number 1 there, that would be the 10,000ths place. Okay, so they're asking us to round to the nearest 100. So when you round, remember that if the number is 5 or larger, you would round up. So if I was to round this number, 12,752, to the nearest hundredths place, I would write 12,800. What, Mr. Glazier? How did you get 12,800? Well, first off, if I'm rounding to the hundredths place, I'm not worried about anything less than that. Okay? And the number just to the right of the number that I'm rounding, and I'm rounding to the hundredths place, that's the 7, is a 5 or larger. Therefore, the hundredths place right there would be the next larger number. So instead of 7, it would become 8. All right? I know this is a lot to remember. Let me write another number. What if I had 24,346? And I said to round that one to the nearest hundredths. Well, first off, where's the hundredths place? That's the 3 right there. So I'm going to look at the number just to the right of it, which is the 4. Is the 4 a 5 or larger? The answer is no. So I would just simply, if I'm going to round to the nearest hundredths, I would write 24,300. I wouldn't change it to 24,400 because that 4 is not a 5 or larger. And we'll do more on that later, but my guess is that you guys didn't remember much about rounding. That's it. Man, this was a long video. I'm sorry your first one was so long, but we're done. You guys finish all of these pages here. Pages, what pages are we talking about here? Pages 6, 7, and 8. Finish. And we will check these on Tuesday, because I'll expect you guys to be watching this video Monday afternoon after our class. All right, that's it.